Alright, in this video we will continue to solve rational equations such as these. I'm starting here with number 7 because this is part 2 of this video. I did problems 1 through 6 on the previous video, so if you haven't watched those yet, you should go back and find that video. Alright, so the method that I'm using to solve these rational equations is to form like denominators and then cancel the denominators out. So I see 2's and x's. So I can make these the same by making them all into 2x. Okay, I can make them all into 2x. So I had to put a new x here in the denominator, so I'm going to need an x up there. I had to put a 2 here, so I'm going to need a 2 up here. I had to put a 2 here, so I'm going to need a 2 here. Now, this is what so many students forget. Maybe I'll change colors just for emphasis. The 1 needs a denominator as well. So don't leave out the 1. So I'm going to have to put a 2x here in the denominator. Alright, I don't know why all my numbers are disappearing. So I'm going to have to put a 2x in the numerator and denominator for the 1 as well. By the way, excluded value x cannot equal 0 because of the x. So now that all the denominators are the same, I can cancel out the denominator and make a new equation based on the numerators. Okay, so I've got 3x plus 2 equals 2x plus 8. Alright, that's my new equation. So I'm going to get these like terms together. So I will subtract the 2x. That gives me x plus 2 is equal to 8. Then I will subtract the 2. That gives me x is equal to 6. Alright, number 8. Again, I need like denominators. Again, don't forget the 2. So I've got this x minus 1 and I've got this x. So I'm going to need an x over here to match that. I'm going to need an x minus 1 over here to match this. But the 2 is going to need all of that. Alright, the 2 needs an x and an x minus 1. Alright, so you got to squeeze that in there. Excluded values real quick. Because of the x, x cannot equal 0. Because of the x minus 1, x cannot equal positive 1. So now I can cancel out the denominators and make a new equation from the numerators. So distributing here gives me negative x squared plus x. Now be careful, right here I have 2x times x minus 1. It's like this, 2x times x minus 1. If I take this 2x and distribute, I'm going to get 2x squared minus 2x. So that's what's happening here. So I'm going to have plus 2x squared minus 2x. Meanwhile, over here I have equals x minus 1. So like terms, so I have negative x squared and positive 2x squared, so that makes x squared. I have x and I have negative 2x, so that's negative x. Alright, so that's it over there, and that equals x minus 1. I am going to get 0 on one side, so minus x and plus 1. So that's going to give me x squared, and then negative x and negative x is negative 2x, and then the plus 1 equals 0. And then I'm going to try to factor this. If it doesn't factor, I will use the quadratic formula, which does happen. X squared can only be x times x. 1 can only be 1 times 1. Inner plus outer must equal middle. Inner I have 1x, outer I have 1x. I can make a negative 2x if these are both negative. And a negative times negative is a positive 1. So I will get the solutions by setting these factors equal to 0 and solving. Alright, so if I set, well, they're the same. So if I set x minus 1 equal to 0, I'm going to get x equals 1. So at first, I think that's the solution. X equals 1. Yay! But then I remember my excluded values. Alright? And one of my excluded values is that x cannot equal 1. So this is not allowed. Alright? So I'm going to throw this out. And because that was my only solution, I'm going to say I have no solution. So the only thing I would put on the answer line, like if this was a test or a quiz, and it was like, okay, number 8, boom. Here's the answer line. Record your final answer here. The only thing I would put here is no solution. I would not put x equals 1 or anything else. I wouldn't even state my excluded values because I already know that nothing works. Okay, that's it for number 8. Number 9. Again, I need like denominators, but the main thing is don't forget about the 1 and the negative 3. So I'm going to put an x here and here, and I'm going to put an x here and here. Alright, so x cannot equal 0. That's my excluded value from the denominator. Now that my denominators are the same, I can cancel them out and make a new equation. So I've got x plus 6 is equal to 2x minus 4 minus 3x. So that's x plus 6. Combining these like terms, the 2x and the negative 3x, that's negative x minus 4. So I want to get these x's together, so I'm going to add x to both sides. So that's going to make 2x plus 6 equals negative 4. So I only see one type of x here, so I'm just going to get x by itself. So I'm going to subtract 6 from both sides. That's going to give me 2x is equal to negative 10. And if I divide both sides by 2, I'm not going to change colors. So if I divide both sides by 2, that's going to give me x equals negative 5. Alright, and that is not excluded, so that's the answer. Alright, number 10. The main thing to watch out for mistake-wise is to make sure that the 4 also gets a denominator of x minus 3. So I'm going to have to put x minus 3 next to the 4 and below the 4. Make sure when you distribute later that you distribute a negative 4, by the way. Excluded value. X cannot equal positive 3, setting any of these equal to 0. So now let's go on and solve it. Since my denominators are the same, I can cross them out. So that leaves me with 6 minus 4x plus 12. Negative 4 times negative 3 is positive 12. And that's equal to 2. Combining these like terms, I've got negative 4x plus 18 is equal to 2. Alright, subtracting 18 from both sides. So that's negative 4x equals negative 16. And dividing both sides by negative 4 gives me x equals positive 4. So that is not excluded, so that's the answer. Well, solving this equation. So I need like denominators, but I really need to factor everything in the denominator first so I can see exactly what I have. So I'm just going to recopy this a little bit. So I have 4 over x minus 3. All right, I've got 2 over x plus 3. And I've got 2x plus 2 over x minus 3, x plus 3. All right, this is the difference of two squares, so there you go. To make the denominators the same, all I have to do is give this one an x plus 3, all right, top and bottom, and give this one an x minus 3. All right, now all the denominators are the same. By the way, x cannot equal negative 3 because of the x plus 3, and x cannot equal positive 3 because of the x minus 3. Now that the denominators are the same, I can cancel them out. All right, I only do this when I'm solving an equation, not when I'm just adding or subtracting. In that case, you have to keep the denominator. So distributive property. So I have 4x plus 12 plus 2x minus 6 is equal to 2x plus 2. So combining like terms, 4x and 2x, that's 6x, 12 and negative 6, that's positive 6. Bringing these like terms together, so I'm going to subtract 2x from both sides. Alright, so this is going to give me 4x plus 6. Alright, I need more room. Alright, so I've got 4x plus 6 equals 2 so far. Yeah. Okay, so now I need to subtract 6 from both sides. I'm just going to get x by itself. So that'll be 4x is equal to negative 4. And then when I divide both sides by 4, I get x equals negative 1. So that's the answer, as long as it's not excluded. So I look back and nope, it's not excluded, so that's the answer to number 11. All right, I think this is the last problem, number 12. So I already see a lot of x plus 6's, but let's not forget about the x. This also needs a denominator of x plus 6. And I'll have to put it in the top and the bottom. Okay. Let's go ahead and mention that x cannot equal negative 6. All right, setting this denominator equal to 0. So now that my denominators are the same, I can cancel them out and make a new equation. So I am going to distribute this, so that will give me x squared plus 6x. Okay, then I've got plus 5 is equal to 6x minus 1. There are no like terms over here, so I'm going to get 0 on one side by subtracting 6x and adding 1. So that gives me x squared. Now these cancel out completely, so I just have x squared plus 6 equals 0. Well, I'm looking at this and I know it's not factorable. It's not the difference of two squares or anything like that. So, but all I have is one term, one type of x. I have x squared, not x squared and x, but just x squared. So the easiest thing to do is to get this by itself and then do the square root. So I will subtract 6 from both sides. And so that is going to give me x squared equals -6. Then I will take the square root of both sides. Alright, be careful not to forget your plus or minus as soon as you take the square root. So that will give me x equals plus or minus. Now, you see I have the square root of a negative number. That means it's imaginary, so I will put I instead of the negative. So I have plus or minus I radical 6. And this is the solution. Yes, it is imaginary, but it still is a solution. It still counts as a solution to the equation. So don't just ignore it. Don't just throw it out the way we do when we're graphing. You know, like if we're trying to find an intersection point, you can't have an imaginary intersection, but you can have an imaginary number. So obviously it's not excluded because it's imaginary. But there it is. That is the solution to number 12.